The recent report on the enigmatic interstellar visitor known as 3I/Atlas has opened an even wider window into understanding this unusual cosmic traveler, deepening the intrigue that has surrounded it since its discovery in July 2025. Astronomers have long anticipated that interstellar objects, those originating beyond our solar system, would occasionally make their way into our planetary neighborhood. But few expected that within such a short period of time, humanity would witness a third confirmed visitor of this kind. As researchers continue to observe 3I/Atlas during its evolving journey around the Sun, a stream of new data has emerged, shedding light on its composition, trajectory, and the curious signs of non-gravitational motion it has displayed. These findings not only reinforce its natural identity, but also spark continued debate among a small number of astronomers who believe the object's behavior may hint at more exotic explanations if certain unusual characteristics were to be further verified in upcoming observations. For now, the scientific consensus firmly aligns with the interpretation that 3I/Atlas is a natural comet, but the nuances in its recent activity have kept the scientific community both fascinated and cautious. At its core, the interest in 3I/Atlas stems from its undeniable interstellar origin. Its hyperbolic orbit, meaning its trajectory is open-ended rather than elliptical, indicates that it is not gravitationally bound to the Sun. This is a critical distinction because typical comets within our solar system travel in closed orbits. They revolve around the Sun repeatedly in long looping cycles. For 3I/Atlas, however, there will be no return. With a calculated orbital eccentricity of roughly E=6, 1373, far surpassing the critical value of one required for an object to escape the Sun's gravitational influence, its path confirms it is an outsider, passing through our cosmic neighborhood on a one-time interstellar voyage. After making its closest approach to the Sun, it will continue on toward the distant reaches of space, eventually departing the solar system entirely and resuming its journey through the galactic void. What has captivated scientists even more is the manner in which the object behaves as it journeys past our star. Like many comets, 3I/Atlas exhibited the formation of a glowing coma, a diffused halo of gas and dust released as the Sun's heat causes volatile materials within the comet's surface to sublimate. The development of this coma, along with other identifiable traits, such as its increasing brightness and the appearance of a faint tail, strongly supports the idea that this is a naturally formed object, rich in ices and carbon-based compounds typical of comets. These features align with what astronomers observed in previous interstellar visitors, such as 1I/Oumuamua in 2017 and 2I/Borisov in 2019, each of which displayed unique but ultimately natural characteristics. The emergence of the coma in particular has been a reassuring indicator to most researchers, since sublimation-driven activity is a classic hallmark of cometary bodies. As such, the outward appearance and chemical behavior of 3I/Atlas leave little physical evidence to suggest anything artificially created by an intelligent civilization. Yet despite all this, questions have persisted about certain elements of its motion. Some astronomers have noted that 3I/Atlas exhibits subtle non-gravitational forces, slight deviations from a purely gravity-driven orbit, which are often seen in comets when jets of gas erupt from their surfaces and alter their course just enough to be measurable. These jets act much like tiny thrusters, pushing the comet in small but detectable ways. In typical comets, these effects are well understood and not particularly surprising. But because 3I/Atlas is an interstellar visitor, even ordinary features can feel extraordinary. The possibility that a comet from another star system demonstrates the same processes as those found locally in our own solar system has significant implications. It suggests that cometary bodies may form through similar mechanisms across different star systems, reinforcing the theory that such icy wanderers are likely widespread throughout the galaxy. However, some speculate that if any non-gravitational forces were found to deviate too strongly or behaved in highly unusual ways, they could hypothetically point to causes not typically associated with natural processes. This line of thought is not mainstream, but remains a subject of curious scientific conversation. Advocates of exotic interpretations sometimes reference how slight anomalies in Oumuamua's motion led to speculation about the object potentially being a form of extraterrestrial technology, such as a solar sail or artificial probe. While follow-up studies later provided natural explanations consistent with comet-like outgassing, the debate nonetheless illustrated how easily unusual interstellar objects can ignite public imagination. With 3I/Atlas, the presence of non-directional thrust-like effects, though easily explained by sublimation, still invites speculation from those who feel it prudent to rule out every possibility, no matter how remote. These discussions do not imply that astronomers believe 3I/Atlas is artificial, but rather that scientific curiosity benefits from considering every hypothesis until evidence fully eliminates it. The new report by Davide Farnocchia of NASA's Jet Propulsion Laboratory plays a key role in dispelling misconceptions and grounding the discussion in empirical data. Farnocchia is well known for his expertise in orbital dynamics, especially in studying the paths of small solar system bodies and identifying whether any near-Earth objects may pose future hazards. His work frequently involves analyzing non-gravitational perturbations, those minor shifts in motion caused by forces other than gravity. In the case of 3I/Atlas, his analysis highlights that all detected non-gravitational activity fits comfortably within the expected behavior of a comet undergoing heating as it approaches the Sun. According to the report, the magnitude and direction of its deviations align with jets of sublimated material escaping from its surface, consistent with natural physical reactions. This further strengthens the argument that no artificial explanation is needed for its observed trajectory. Another major point of interest is that 3I/Atlas contributes significantly to the growing body of evidence, suggesting that interstellar objects may pass through our solar system far more often than previously believed. Before 2017, no such object had ever been confirmed, and astronomers assumed that interstellar visitors must be exceedingly rare. Yet within just 8 years, 3 such objects have been identified. This shift in understanding could stem not only from increased detection capabilities, thanks to more advanced telescopes and increasingly comprehensive sky survey programs, but also from the realization that the galaxy may be rich in small bodies frequently ejected from developing planetary systems. In many star systems, gravitational interactions can fling comets or asteroids into interstellar space, sending them drifting indefinitely until they encounter another star's gravitational field. In this sense, 3I/Atlas is not just an isolated visitor, but a representative of an entire population of interstellar debris that may be passing silently through our cosmic neighborhood on a regular basis. These objects carry immense scientific value. By studying them, astronomers gain rare insight into the chemical and physical properties of other star systems without needing to send spacecraft across unimaginable distances. The materials that compose comets like 3I/Atlas can reveal clues about the environments where they formed, potentially offering glimpses into planetary system formation beyond our own. If their compositions differ greatly from comets native to our solar system, this could indicate exotic chemical processes occurring elsewhere in the galaxy. On the other hand, if their compositions are similar, as current data suggests for 3I/Atlas, it may reveal that the building blocks of planetary systems are remarkably consistent across different regions of the Milky Way. This has major implications for understanding planet formation, the distribution of water and organic molecules throughout the galaxy, and even the likelihood of life arising in distant star systems. Despite all the scientific excitement surrounding 3I/Atlas, the discussion about whether it could exhibit signs associated with artificial origin remains an extremely minor viewpoint within the research community. Most astronomers agree that nothing observed so far suggests the object is anything other than a naturally formed comet. The coma, the sublimation-driven non-gravitational motion, and the hyperbolic orbit are all consistent with what one would expect from a frozen body that has spent millions or even billions of years traveling through space before happening to pass through our solar system. While some experts propose that it is important to keep an open mind when examining interstellar objects, owing to their unfamiliarity, There is little concrete evidence to prompt serious consideration of an extraterrestrial technological explanation. Even the unusual aspects of